Next, we are going to discuss about the one of the important chemical reaction of alcohol is called esterification reaction. Esterification means R C double bond O R dash. That is called two oxygen atoms will be there in the ester compound. Let's see how the alcohols which is going to form the ester. We can see here that is called esterification reaction. I mean ester will be formed during the product. So let's see here. First I take this acid, that is called carboxylic acid. Whenever the carboxylic acid which is going to treat it with the alcohol, it is called ROH. ROH is nothing but alcohol. That is, if I take this R dash and this is the R. So that is called whenever the alcohol which is going to treat it with the carboxylic acids in the presence of concentrated H2SO4, that is called hydrating agent. Whenever this concentrated H2SO4 which are going to use in the reaction, that makes removing the water from the reaction. It acts as a dehydrating agent. It acts as a dehydrating agent. Dehydrating is nothing but removal of the water, in the reaction. So finally, so how they are going to remove the form of the water? So like this. So removal of the water by using this concentrated H2SO4, we are going to obtain the ester. So like this. What is the remaining? When I remove this water molecules, what is the left here? R dash, C double bond O as it is, and next O R. So this is called ester. Its name is called ester. This is called ester, and what I have removed here? I have removed the water molecule. So that's why this type of reaction we are going to call as esterification reaction. So let's see one example. So in this case of this acid, I will replace R dash with CH3. It is called acetic acid. CH3, C double bond O, OH. This is called acetic acid. And in the place of this alcohol, I am going to replace R with C2H5. That is called ethanol. Whenever I use this concentrated H2SO4, so it is going to remove the water molecules. So that is called OH from the acid group, H from the alcohol. Combining, water will be removed, and what is the remaining product I am writing here? It is in the form of ester. That is called CH3, C double bond O, and O, C2H5. This is called ester, and its name is called ethyl acetate. Its name is called ethyl acetate. So like this, we are going to obtain the ester, and based on this reaction, we have summarized some of the information. Let's see here. Esters are fruity smell. Esters are always having the fruity smell, and hence esterification reaction can be used as a test for the carboxylic acids. So this esterification test we are going to use for the testing for the carboxylic acid. During this reaction, OH group of the acid which is going to combine with the H of the alcoholic group like this. OH of the acid and H from the alcohol which is going to combine. What is happening? Removing the water molecules. Like the next one. The reaction is reversible. Reversible means, so this reaction is again it forms the acid. Whenever the product ester is formed, which is going to reversible means again it is going to make happen with acids and alcohols. As soon as what happens, water is removed. As soon as it is formed, once again formed and removed. Why? Because this is a reversible reaction. Last point is introduction of acetyl group. That is called CH3CO group. That is called CH3CO group. So introduction of this acetyl group, we are in alcohols or phenols, we are going to call it as acetylation. This is called acetylation. So like this, we are going to study the esterification reactions in alcohol. Next chemical reaction of alcohol is called dehydrogenation. What do you mean by this dehydrogenation? D means removal, like this. Okay. So we are going to remove the hydrogen gas from the reaction. That is called dehydrogenation. So let's take this here alcohols. Primary alcohols, what happens when it is going to treated with the copper catalyst at 573 Kelvin, we are going to obtain the aldehyde. So like this, secondary alcohols, when it is going to treated with the copper catalyst at 573 Kelvin, we are going to obtain the ketones. Let's see with primary alcohols. We know the general functional group of primary alcohols. We are going to call as RCH2OH. This is called primary alcohol. When it is going to treated with the copper catalyst at 573 Kelvin, we are going to remove the hydrogen gas from this compound. That is, this hydrogen gas which is going to be removed from this alcohol, we are going to obtain the aldehyde. We are going to obtain the aldehyde. This is aldehyde and this is primary alcohol. Let's see one beautiful reaction. So if I replace tar with that is CH3, that is called CH3 CH2OH. We are going to call it as ethanol when it is going to take place under the catalyst that is called copper at 573 Kelvin. We are going to remove the hydrogen, right? So we are going to remove the hydrogen gas. What we are going to obtain here? When you remove this one, we are going to form the that is called acetaldehyde. CH3, this will be acid, this will be there. CH3 CHO. CH3 CHO. Its name is called acetaldehyde. Its name is called acetaldehyde, and this name is called ethanol. So this is how the reaction takes place when primary alcohols under the catalyst. We are going to obtain the respective aldehydes. Similarly, this is the first case. Let's see the second case, that is secondary alcohol which is going to be treated with copper catalyst. We are going to obtain the ketone. How? Let's see this one. R, because secondary alcohol means 2 R group will be there. That is R2CHOH. I rearrange it like this because to remove the hydrogen, that is also very easy. So under the copper catalyst at 573 Kelvin, what we are going to remove? Hydrogen gas. So this hydrogen gas will be removed. How it is going to remove? So you know that the oxygen and hydrogen electronegativity parameter. Oxygen will have the more electronegativity. So what happens? It obstructs the bond pair of electron towards itself. This hydrogen will be eliminated as a H plus, and here also when it becomes double bond, carbon becomes 1, 2, 3, 4, 5. So in order to this will be also migrated. This will bond moves. So like this, 2 hydrogen will be eliminated as a hydrogen molecule. That is the remaining as ketone. R C double bond O R dash. That is called R C double bond O R dash. R C double bond O R dash. Because the electronegativity parameter, this bond migrates here and this bonds break down. Hydrogen gas is eliminated. This is called ketone. So I take one example. I take example of isopropyl alcohol. Isopropyl alcohol is CH3 CH3. That is R dash function group. That is what is remaining? OH. Right? So that is called isopropyl alcohol. Iso means this will be the branch with this normal chain. This is called isopropyl alcohol. When it takes place under the same that is copper catalyst at 573 Kelvin, we are going to remove the hydrogen gas. We are going to obtain the acetone. That is CH3 like this R and C double bond O. Where this one? C double bond O. This hydrogen has removed here, and what is the remaining? CH3. Its name is called acetone. Its name we are going to call as acetone. So this name is called isopropyl alcohol. When it takes place under the reaction, we are going to obtain the acetone. We have removed the hydrogen gas. So what about the tertiary alcohols? What we are going to obtain here? Let's discuss. Before this one, we are going to summarize this one. So whenever the primary alcohol which is going to take place under the copper catalyst at 573 Kelvin, we are going to obtain the aldehyde, and similarly secondary alcohols when it takes place under the same condition, we are going to obtain the ketone. What about the tertiary alcohol? So tertiary alcohols which never use the dehydrogenation, because when you look at this one, primary alcohol and secondary alcohols, we have the 2 hydrogen atoms sufficient will be there. What about the tertiary alcohol? Let's see that example. If I take this one, CH3 and this is a CH3. So like this is called tertiary alcohol. Tertiary alcohol is 3 CH3 group there. This is a CH3 unit. 1 CH3, 2 CH3, 3 CH3, and this is a OH group, right? So here this does not undergo hydrogenation because that, so here 3 R group will be there. So that's why only hydrogen will be there. Due to this insufficient hydrogen atom in the tertiary alcohol, which never undergo dehydrogenation. Instead that it is undergo dehydration. That is called dehydration. Under the same condition only. So we are going to remove the water molecules. We are going to remove the water molecules. We are going to obtain the alkene. That is CH3 double bond CH2. So like this we are going to obtain the alkene. So tertiary alcohol when undergoes the copper catalyst, we are going to remove the water molecules. removing the water molecules, we are going after the alkene. So that's why tertiary alcohol does not undergo dehydrogenation, because of the insufficient hydrogen atom in the tertiary alcohol.